Hello, this is Hui. Welcome to watch my video, C++ programming on Linux. In previous video, we have walked through how to encrypt, decrypt using WolfSSL AES CBC algorithm. And in this short video, we are going to discuss Wolf RSA algorithm, one of a very important algorithm and be widely used in secure data transmission applications. RSA algorithm is a public key cryptography algorithm, which means it works on two different keys, public key and private key. The public key is used for encryption and is known to everyone, while private key is used for decryption and must be kept secret by the server. Almost every cryptographic library supports RSA algorithm. WolfSSL supports many common used algorithms, include RSA algorithm 2. In our channel, there are two RSA cryptography related videos. One video example was using OpenSSL library. A software library is a robust commercial grade full-featured toolkits for general purpose cryptography and secure communications. Another video example was using Crypto++ library, a free and open source C++ class library of cryptographic algorithm and schemas. In this short video, it's going to write two C++ program examples using WolfSSL RSA algorithm to generate a key certificate and walk through basic steps of how to use RSA algorithm in security communication project. You can compare all these three libraries and make your own decision for your project. Here on our Linux environment, first we write a program, WolfSSL RSA keygen.cpp. This program is used to generate RSA private key and public key. The usage will take three arguments. First argument is the key size, second argument is the private key, and the third argument will be the public key. As we know, all Wolf crypto process will be start from the Wolf crypto init, end up with Wolf crypto cleaning. Wolf crypto init initialize resource used by Crypto. Wolf crypto cleaning is used to clean up resource used by Crypto. To generate RSA private key and the public key, first we need to get the seeds and the key cipher for RNG. Function wolf init RNG is used to get the seeds from OS and the key cipher for RNG. This function takes one parameter, WCRNG pointers. First, declare variable RNG. Before we end, clean the RNG allocated memory. Function. Next, initialize provided RS key struct. Function wc init RSA key. Function wc init RS key. This function initialize a provided RS key struct, and the WolfSSL library recommended using xmalloc, xfree, and xrealloc to handling memory allocation and reset. This function is defined in the RSA.h. there's two functions to initialize RSA key. One is WC init RS key, and another one is WC init RS key underscore EX. Second function has device ID from the device. We declare variable RSA key name new key. First parameter is new key. Second parameter is the heap identifier. Since we don't use a heap, none. Invalid def ID means we don't use def ID. Next, we'll allocate memory. Since WolfSSL library recommended use xmalloc, we name it a key buffer equal. First parameter is the size. Second parameter is the heap, since we don't use none. And the third parameter will be the memory type. malloc is not an actual function, it's rather a pro-processor macro which allows the user to substitute in their own malloc, realloc, and free function in place of the standard C memory functions. C++ pro-processor directive a line included in the code of a program preceded by the hash sign pound. This line are not program statement but directive for preprocessor. The syntax for define the macro is hash define, identifier, and replacement. It replaces any occurrence of the identifier in the rest of the code by replacement. WolfSSL library uses a lot of preprocessor directives, include conditional inclusions. This directive allows include or discard part of the code of a program if certain condition is met. This is useful for compile a program with lightweight. Back to our editor. After allocated memory, we reset memory. Next step, to generate a private key. Function WC make RSA key. Function WC make RSA key. This function generate a RSA private key in the length of size and a given exponent e. It then stores this key in the provide RSA key structures that it may be used for encryption and decryptions. This function takes 4 parameters. First is RSA key pointer, the size of key, exponent e, and RNG random number generators. First parameter is new key. Second parameter is the key size from command line argument 1. Third parameter is exponent RNG. Next step will convert RSA key to DER format. The RSA key can be saved in PEM format or DER format. In previous video, we have created RSA key using PEM format. In this short video, we create a key using DER format. Function will be RSA key to DER. Function WC RSA key to DER. This function converts an RSA key to DER format. The result is written to output and it returns the number of bytes written. This function takes 3 parameters. First is the RSA key pointer. Second, the pointer of output buffer, and the length of buffer. Return is the number of size. First parameter new key, second parameter, key buffer, and the key size. If key size less than 0, we're going to process error handling. And next, we'll write key into the private key files. File name from argument 2. So this is a basic open a file, write a buffer to the file, and close the file. Next step, convert RSA public key to DER format. First, copy this line. We reset memory key buffer function to convert RSA public key to DER format will be WC RSA key to public DER underscore EX. Function WC RSA key to public DER underscore EX. This function convert RSA public key to DER format, write to output, and return count of bytes written. This function takes 4 parameters: RSA key pointer, pointer of output buffer memory, the length, and the flag with header. If with header is 0, then only the sequence N and E is written into ASN1 DIR format, and with excluded the headers. Back to our editor. First parameter, new key. Second is buffer, pointer, key size, and 0 without headers. Then we write the buffer date into the public key files. Copy these 5 lines. File public, argument 3. Create public key files. And print out message, successfully generate a RSA public key. Before we exit, free the memory, key buffer, memory type, key type, and free the RSA keys. Function WC free RSA key. WolfSSL library. Based on the type of use, you can define dynamic key types for memory allocations. Macro dynamic type key is defined in the types header files. Here is the memory allocation type used: type CA, type certificate, type key, and type RSAs. So in this demo example, since we are create RSA key, we just use dynamic type key. Now we finish our program, we save our program, and we compile our program. Now program has been compiled. This is our executable WolfSSL RSA keygen. Next, we are going to test our program. The usage, first argument is a size 2048, my private key.der, and my public key.der. So now we successfully generate private key, my private key.der, and the public key, my public key.der. Here is the public key and the private key we generated. We use OpenSSL command line command to check the private key and the public key. format is DER. So our RSA key is okay when we use OpenSSL command line command to check. To parse private key and the public key we generated command my private key.der. Here we parse the private key. My public key.der. Here you can see the public key is only N and E, and the private key has more components. Now we successfully generated private key and the public key. As we know, the most popular usage of RSA public key crypto system is to generate certificate for secure data transmission applications. Now we create a new program, WolfSSL RSA CertGen.cpp. This program is used to generate a private key and certificate. We are going to import from our previous example, WolfSSL RSA keygen WolfSSL RSA keygen.cpp. The usage will make small adjustment. First argument is the key size, second argument is the private key, and the third argument will be certificate. And the first part, create and write a new key to DER format is the same. Second part, after we successfully generate a RSA private key, we are going to memory set and generate certificate. Copy this 4 line. We'll delete line 63 to 69. 63, 69D. To generate a new certificate, first initialize certificate function wc underscore init cert. Function wc init cert. This function initializes a default cert with the default option version equals 3, serial 0, and the sign type SHA with RSA issue is blank. This function has one parameter pointer of cert structures. Back to our editor, structure new cert. Next, we'll write in the subject. First is country, CA. The state, ON. The locality, organization, home, unit, home office, we can optionally put email, but in this example, we just skip this. New cert is CA, we just put 1, and the new cert sign type. WolfSSL sign type has been defined in the header file asm public.h. Here is a defined type of signature. we just pick up CTC SHA 256 WRSA type. Next step is create new self-signed certificate function WC make self-cert. Function WC make self-cert. This function is a combination of previous two functions, make cert and sign cert for self-signed certificate. It makes certificate and sign it, generate a self-signed certificate. This function takes 5 parameters. First is pointer of a certificate. Second is buffer. Third is buffer size, RSA key pointer, and the RNG pointer. Back to our editor. First parameter, new cert. Second parameter, the buffer. Third parameter is the buffer size. RSA max size. Key. Printout message, successfully created new self-signed certificate. Next, write certificate into file. From argument 3, so we open file, write a buffer into the file and close the file. We make some typing error. Now we correct our error and we free our memory, free our key, free RNG, and clean up. Now we finish our program. We save our program. We compile our program. Now programmer has been compiled. Executable WolfSSL RSA cert gen. Now we are running our executable. Usage size 2048, my private key, and my certificate.der. We have successfully generated a private key and the self-signed certificate. Here is our private key and our certificate. To check our private key, our private key, RSA key is OK. To parse certificate, command will be here is our certificate, version 3, serial number, algorithm, SSL 256 with RSA encryption, and here is the public key 2048-bit, and the signature algorithm is SSL 256 with RSA encryptions. To test our private key and the certificate, we can use preview videos example, SSL TLS Echo Server and HTTPS server. Here is the program we created in preview video. Open SSL TLS server.cpp. In that example, our certificate was loaded from file in PEM format. Now we change it to ASN1 for DER format. We save this program. We recompile this program. Now our program has been recompiled. For testing, we copy our certificate and the private key to this directory. To test our new created certificate and the private key, we are using two terminals. On the top terminal, we are going to run a server. The usage will be first argument is port number 1234, And next is a certificate, which is my certificate.der. Third parameter is private key, my private key.der. Now our TLS SSL echo server has started, and we're going to run our client. At the bottom terminal, usage will be the host and the port number 1234. Send a message. This is Hui test new DR format certificate message 1. Our server received the message and server replied the message. This is Hui second test new DR format certificate message 2. Server received the message, reply back, and the client received the message. Here is another example from previous video. EV HTTP HTTPS server.cpp. In this program, we are originally take a certificate in PM format. We make an adjustment to accept the certificate from DR format. Now we save our program. We compile our program, and the program has been recompiled. Now we copy certificate to this directory. To test our new certificate using preview videos HTTPS server, we using two windows. On the top is a terminal running on HTTPS server. Host is 10.0.0.191, and the usage will be first is port number 1234, certificate, which is my certificate.der, and the private key is my private key.der. Now our HTTPS server has started listening on the port number 1234. The bottom is a web browser. We're going to run https://10.0.0.191 port number 1234. So now I see our web browser is able to send a GET request to our web server, and our web server reply back. This is a Hui test lab event HTTP to HTTPS server. So now you can see my certificate in DR format and my private key in DR format work. Hello, this is Hui. Thanks for watching my video. Wish it helpful, and it's going to be great to have your feedback.